Welcome back to this live lesson series on the equation of a straight line. If you haven't already, I highly recommend that you watch these 3 lessons as prior knowledge, because a lot of the things that you would learn in those lessons is what I will just be talking about as if you already know it in this lesson. So I won't be over explaining things that I've already explained in those lessons. Today we'll be expanding on what we learned in the last lesson, which was the equation of a straight line, y equals mx plus c. And we'll be seeing how do we take a graph and form the equation y equals mx plus c. So, like I said, if you haven't, pause the video, go and watch those other ones, and then come back to this one. If you have, we can crack on with equations of a straight line 2. Now, equations of a straight line 2 is where we're going to take a graph that has a straight line on it and use what we learned in the last lesson, y equals mx plus c, to form the equation. So if we just focus in on this remember me, this is what we should already know. The general form of the equation of a straight line is y equals mx plus c, where m is the gradient, and we know the gradient is up divided by across. So when you draw the triangle on the line, it's how many up do you go divided by how many across you go. Okay, and we'll talk about that again. We'll sort of recap that. And then the plus c on the end is the y-intercept. So that is where the line crosses the y-axis. So if you know that formula well, and you understand what the gradient is, and you can understand what the y-intercept c is, this lesson is very easy. It's just piecing it all together. So if we take example 1. Example 1 says, find the equation of the line. So we know as soon as you see the equation of the line, you should write down y equals mx plus c, because that is what you're going to have to fill in. We now need to find out what is m and what is c. Now the easiest one of those is c, because c is where the line crosses the y-axis. It stands for the y-intercept. Well, that is obvious. When you look at a straight line, all you need to do is look at your y-axis and find where does this line cross it. And clearly it crosses it here at 1. So we would say that the y-intercept c, if I put that in pink as well, is 1. Okay, so the y-intercept c is 1, and we will come back to that when we go to fill in our equation. So c is 1. The next thing is the gradient. Now we said about the gradient, it is very, very important that when you're forming your triangle on the graph, it has to be on the grid. So for example, this starting here is a very bad triangle to draw because it's on that grid in the background. Okay, you want to make sure that you draw your triangle on that grid. So with that being said, I could draw it anywhere and as big or as small as we want, and we saw this in the gradient lesson, providing it is on the grid. So I'm just going to start from the 1, I'm going to go across, and then I'm going to go up. And as you can see, the 2 points that I've used definitely fall on that grid in the background. Then it's a case of being careful with the scale. We discussed how important it is that 1 square does not always mean 1 unit. But in this case it does, so that's okay. 1 square is worth 1 unit. So how many across is it? It's 1 unit across. And how many up is it? Well, the y is also 1 unit, so it is 2 units up. Once you form that, we could say that m, the gradient, equals up divided by across, which would be up is 2, across is 1. Therefore, the gradient is 2. And we know if the gradient is 2, that means you go across 1 and up 2. So we have all of the elements that we need now to write the equation of a straight line. Remember, the y and the x is just the y and the x coordinates, so they're always in the equation of a straight line. So all we have to say is that the equation of a straight line is y equals m, which we just said the gradient is 2, x, plus the y-intercept, which in this case the y-intercept is 1, so plus 1. And that is that question complete. We have written the equation of the straight line, which is y equals mx plus c, where we have filled in the gradient from finding it from the graph, which is what we learned before any of this stuff, and then identifying where does this line cut the y-axis, which is plus 1. And that is that question complete. So knowing y equals mx plus c, really important. If you don't know that, you can't do this question. Knowing how to find the gradient from a graph, Very important. And the easiest part of it all is identifying where does it cross the y-axis. What is the y-intercept? So example 2. Find the equation of the line here. Well, first of all, as always, we're going to write y equals mx plus c because I know that is the equation of a straight line. The easiest part of all of this is to identify the c. Remember, c is the y-intercept. Where does this red line cross the y-axis? Well, that is obvious. It's easy. -6. And then the tricky part is to find the gradient. First of all, is this a positive or a negative gradient? We learned that positives go this way. And you can see there, just to the right, that's a negative gradient. Example 3 is a negative gradient because it's going in the downward direction if you read it from left to right. So we've established that the gradient will be positive. Now we need to draw a triangle. And we have to be really clear. This triangle has to start on the grid in the background. If it doesn't, it's going to be very difficult for you to know how many units across it is. So providing you stick to that, maybe we'll do a bigger one this time just to prove that it doesn't matter how big or how small you draw this triangle. I'm just going to go from this point here and I'll go across, I don't know, to here, and I'll go up to here. And as you can see, both of my points that I've picked fall on the grid in the background, so that's fine. Now it's a case of deciding how many units across, not squares, units. How many units across is this? And how many units up is it? And you do not just count the squares, and we spoke about that quite in-depthly in the last lesson on finding the gradient, that you do not just count the squares, you look at the scale. And as you can see, on the x-axis, 1 unit is actually worth 2 squares. So if you just counted these squares here and called them all 1, you'd be wrong. So 1 unit is 2 squares. So we've got 2 squares would be 1, and another 2 squares would be 2. So it is 2 across. Yeah. And we can see clearly to go from -1 to +1, it's across 2. And then check your y-axis scale. Well, clearly 1 square is worth 2 because it's going 2, 4, 6. So 1 square is worth 2. So what do we have here? We've got 2, 4, 6, 8. So it's going 8 up. Here we can say, well, what is the gradient? Well, the gradient, remember, is m equals up divided by across, the change in y divided by the change in x, which in this case would be up is 8 and across is 2. So the gradient is 4. Gradient of 4 means that every time you go across 1, you go up 4. Or, in this case, cross 2, up 8. It's the same thing. But if I went across 1, which would be 2 squares, how many do I go up to hit the line? 2, 4. So across 1, up 4. No matter what triangle you use, you will always get the correct gradient if you read the scale properly. So we've established the gradient is 4. We've spotted that the y-intercept is -6. So therefore, we can fill in y equals mx plus c. We could say that the equation of this straight line will simply be y equals m, which is 4x, plus c, which in this case, our plus c is -6. So I don't have to write plus -6. I can just write -6. Okay? Don't get into the habit of writing plus -6. If c is negative, there is no plus. It is just -6. Okay, so simple as that. And what you should be able to do is, if I showed you this from last lesson, we learned that if you saw this equation, you would instantly know, oh, the gradient is m, which is always the coefficient in front of the x, so the gradient is 4, which means every time you go across 1, you go up 4. And you would notice that that -6 would stand for the y-intercept c. So you need to be able to link both looking at the equation of a line and being able to identify what it means, but also what we're doing today, which is here's a line, tell me the equation of it. And if you can do those two things really well, the equation of a straight line is quite straightforward. But it requires you to know small elements of the gradient, finer details like being careful with the scale, making sure your triangles are on the grid, and it requires you to know the form y equals mx plus c. So we can take all of that, and it's the same every time, into example 3. So example 3 wants us to find the equation of the straight line that is shown in red here. And we said a minute ago that that is going down. Yeah, if you read that from left to right, it's going down. So it's going to be a negative gradient. So that's something we should keep in mind. We know the equation of a straight line is in the form y equals mx plus c. So we need to make sure that our equation looks like that at the end. The first and easiest thing we could identify is what is the c, what is the y-intercept? Well, here clearly this line crosses the y-intercept, or the y-axis, at 10. Then it's just a case of finding the gradient. Well, again, we can draw this triangle anywhere. We've proved in the first example and the second example that a small one will get you the gradient, a bigger one will get you the gradient. We could even do a bigger one here and get the gradient, but no matter where you do your triangle, you should get the same gradient that I would. So maybe you would, if you're feeling confident, maybe you could try and draw a different triangle to me and see if you get the same result. I'm just going to put mine from here, and I'm going to go across, and then to get to the line and make sure that I hit it on the grid, I would have to go all the way to there. And that way we can see that I am on the grid in the background with my 2 points. That will make working out how many across it is much easier. So how many across is this? Well, is it 1, 2, 3, 4 across? Check the scale. Look at the x-axis. The x-axis, 1 unit is actually 2 squares. So it isn't 4 across. It would be 1. So 2 squares is 1 unit. And then across another 2. So that would be 2. So it's actually only 2 across. Yeah. If I just counted the squares, I would have written 4 there, which would have been wrong. So checking the scale is really important. How many down is it? How many down do I go to hit the line? And because this is negative, I can go down. It is 2, 4. Remember the scale, check it. Every square is worth 2 units. So here we're going down 2 squares, which would be 4 units. 2, 4. So once we've established that, we could say, well, m equals up divided by across, where up is 4 and across is 2. 4 divided by 2 is 2. Now, this is really important. We went across and down, and we've already established that this line is a negative gradient, so we have to slap a negative sign in front of this 2 to show that the gradient is minus 2. So the gradient is minus 2. Across 1, down 2 is what that means. Every time you go across 1, you go down 2. Or across 2, down 4. Same thing. So we've got everything we need now. We've got the gradient, which is minus 2. We've got the y-intercept, which is minus 10. So we can write down the equation of this line. This line would be y equals m, which is minus 2x, plus c, which our c in this case is 10. And that would be that question complete. Okay, so that takes us on to example 4 and 5, where I've just put in here some different grids where it might be a little bit harder for you to identify, and a lot of students find these grids harder to see, and sometimes I do as well, because you've got the tiny little squares as well in the background. But if we stick to our methods, we should be fine. What's it asking for? It's asking for the equation of the line. So that means we know the equation of a straight line is y equals mx plus c. I need to identify the easiest one first, which is the plus c. Where does this line cross the y-axis? Well, this is interesting. The y-axis is here. This line is going through it right here at the origin. So it's going through it. We call that the origin. And we know that at the origin, both x and y is 0. So we'll come back and we'll discuss that when completing this question, but it's crossing the y-axis at 0 essentially. Let's get a triangle going to show our gradient. Now, we have to make sure that we are on the grid. So a really bad place to start my triangle would be here. Yeah. We want to make sure we're on this bigger grid here, this bigger grid with the big squares. If we can make sure it falls on those points there, it will map with our units down here. So the best place to start this triangle could be from the origin. You can usually go from wherever it crosses the y-axis, because that would definitely be on the point, and I'd have to go all the way across to here to then go up to make sure that it's on one of those grids in the background. So how many across is that? Well, I can clearly see that as across 2 units. And how many up is it? Well, it's up 1 unit, look. One of these squares here is 1 unit there. So that would be up 1. So what can we say? We've accurately drawn our gradient. First and secondly, is it positive or negative? Well, this is going in an upward direction. It's not very steep, but it is going in an upward direction. So it's a positive gradient. So we can say m equals the gradient is up divided by across, which in this case up is 1 and across is 2. So our gradient is a half, and we spoke about having fractional gradients. They are absolutely fine. Fractional gradients, what does this mean? Basically, it means every time you go across 1, you go up a half. Or, an easier way to think about it is, every time you go across 2, you go up 1. And we've seen that, look, across 2, up 1, across 2, up 1, across 2, up 1. That's how we'll create our straight line. Or, across 1, if we focus in, look, across 1, what's that up? Well, that's up a half, look. That's 1 there, this is 0, that would be a half. So that works as well, across 1, up a half. So that's the 2 ways you could think about a fractional gradient. It's easier just to think of it as a fraction where the bottom is across and the top, the numerator, is up. So we've got everything we need now. Y equals m, which in this case is positive a half, x plus c. Well, what was c? C was 0. It crosses the y-axis at 0, so plus 0. We spoke in the last lesson, it's absolutely pointless for me to write plus 0, and it looked very strange. So if it crosses at the origin, and we'll make this note, really good note for you to add. If it crosses at the origin, so if the line, or if a line, any line, yeah? If a line crosses at the origin, which means the y-axis is 0, you don't have to write plus 0 for c, okay? And we know, don't we? Hopefully me using the word c, you know I'm talking about the y equals mx plus c. If a line crosses at the origin where the y-axis is 0, you don't have to write 0 plus 0 for c. So we just leave it blank, and we should know that if there is no plus c, it means it crosses at the origin, and we looked at that yesterday. So that takes us on to the last and final example of today, where hopefully this is just really cementing in your head what you learned in the last lesson, which was how the equation of the straight line works and what the different elements are. Now we're seeing it live in action. If we've got this straight line here, and we want to write down this equation, well, the equation of any straight line would be in the form y equals mx plus c. The easiest thing for us to identify is the plus c, which in this case here, it's not plus, it's minus 1. It's crossing at minus 1. Okay. Now the gradient, where that requires a little bit more work, but we're going to draw a triangle. Now again, you can draw the triangle as big or as small as you want, providing it is on the grid in the appropriate way that we've discussed. You're going to get the correct answer. Is this a positive or a negative gradient? Well, hopefully you're thinking to yourself straight away, that's negative, it's going down. Yeah, and we spoke about if there's a little stick man at the left of any line and he walks to the right, what would happen? He would go down. So it's a negative gradient, so we have to make sure that we remember that. And it might be worth just writing at the top, minus. It's a minus gradient, okay, at the top of the line, so you don't forget. Where's a good point to pick? Well, this is a good point. This is a good point. Where else is a good point? Well, this is a good point. So this graph is limited to the amount of points that we can pick. There's only 3. I'm just going to pick this triangle here. Okay. So I usually go, and here's a good tip, I usually go from the y-intercept because I know it's going to be a decent point that we can use. So from here to here, and as you can see, again, I've made sure that my gradient triangle is definitely on the grid where we're talking about proper units. Yeah, definitely on the x as well. How many across is this? Well, we have to be careful. Let's check the scale. It's 1 across and then 2 across. So it's 2 across. And how many down is it? Well, that's 1. That's 2. That's 3. It's 3 down. So it's 2 across and 3 down. And remember, it's a negative gradient, which we've made a note of there. So this would mean that m, the gradient, is equal to up, change in y, divided by across, change in x, which would be up is 3, and down, across is 2. And we have to remember this is a negative gradient, it's going down, so I'm going to write a negative sign in front of that. And again, what we've got here now, for the first time today, we've seen a negative fractional gradient. Don't be scared of it, it's fine. What does it mean? It means every time you go across 2, across 2, you go down 3. And I know it's down because it's negative. And we've just seen that there. Every time you go across 2, you go down 3. And if I started my triangle here, it'd be across 2, down 3, across 2, down 3. Or it's across 1, down 2/3, 3 over 2. Across 1, down 3 over 2. And that would be 3 over 2, which would be 1.5. Okay, so as you can see, 3 over 2 is 1.5 as a decimal, and you can see there, if I go across 1, it is actually going down 1.5 because that is 1 square, and that little bit there is definitely a half. But it's much easier to keep it as a fraction and just think across 2, down 3. And I know it's down because it's negative. So we have everything we need now. We've got the gradient and we have identified the y-intercept. So we could say that y equals m, which is minus 3 over 2x, plus c, which in this case our c is not plus, it's minus 1. And that would be our final answer for this question. So really, today's lesson was just taking the elements that we've learned of the gradient of a straight line, how that works, how we can find it from a graph, the equation of a straight line, y equals mx plus c, and how those elements work, and just piecing them together where we're taking a line and we're writing down the equation of it. So takeaways, again, as last lesson, y equals mx plus c, and the gradient is m equals up divided by across, and c is the y-intercept. So thank you for joining in. Next lesson we'll be looking at how do we get given 2 coordinates and find the equation of that line strictly from coordinates, no graph or anything like that. Okay. So thank you for joining in. I hope you learned something, and I will see you in the next one.